Welcome to This Explainer. Today, we are breaking down everything you actually need to know about the Big Bang Theory, separating the hard mathematical facts from the pop culture myths. I am incredibly excited to guide you through this because the true, verifiable story of our universe's origin is far more fascinating and honestly, way stranger than any fiction.
So what instantly pops into your head when I say the Big Bang? I'd bet a lot of you immediately think of the hit television sitcom, or maybe you picture a massive, fiery explosion tearing through the cosmic darkness. Well, neither of those gives you the full scientific picture. The reality is profoundly different and, dare I say, a lot more elegant than just a giant space explosion.
Look, let's clear up the absolute biggest misconception right out of the gate. The Big Bang was not an explosion of a single point into some empty, pre-existing surrounding room. It wasn't just matter flying outward through space like shrapnel. Rather, it was the intrinsic expansion of space itself. The container got bigger, carrying everything along with it. This is exactly why scientists often prefer a much more accurate name for it, the everywhere stretch.
Okay, so here's our roadmap for today. First, beyond the sitcom. Second, the everywhere stretch. Third, the priest and the primeval. Fourth, discovering the cosmic fossil. And finally, singularities and unanswered questions.
Starting off with Section 1, Beyond the Sitcom.
You know, the wildly popular show's impressive scientific accuracy was no accident. It was meticulously curated by UCLA physics professor Dr. David Saltzberg. He made sure the characters were discussing real, incredibly complex concepts, like the Hubble law, which observes that distant galaxies are moving away from us, and the Doppler effect. They also accurately reference the universe's origin as being about 13.8 billion years ago. What's so brilliant about this is that it brought high-level academia straight into millions of living rooms every single week, making these massive scientific ideas super accessible to the general public.
Moving right along to Section 2, the everywhere stretch.
Okay, so the crucial takeaway here is that the universe began from an initial state of unimaginable density and temperature, but from that very first moment, it hasn't been expanding into a pre-existing void. The fabric of space itself has been stretching everywhere, simultaneously, ever since. Imagine baking a loaf of raisin bread. As the dough rises in the oven, every single raisin moves away from every other raisin. But to make this analogy perfect for our universe, you have to imagine a loaf with absolutely no edge, no crust, and no center. Space itself is stretching everywhere at once as a direct consequence of general relativity. There literally is no center to the universe, because every single point is stretching away from every other point.
Which brings us perfectly to Section 3, the priest and the primeval.
So who actually first came up with this totally mind-bending concept? Well, tracing the history, we start back in 1922 when physicist Alexander Friedmann derived the mathematical equations for an expanding universe. But the real unsung hero stepped up in 1927. George Lemaitre, who was incredibly both a brilliant physicist and a Catholic priest, proposed that the universe emerged from an expanding primeval atom. It was a wildly radical thought at the time. It wasn't until 2 years later, in 1929, that Edwin Hubble published his famous observational law, proving that galaxies are indeed moving away from us, finally backing up Lemaitre's pioneering idea. Lemaitre had this beautiful way of explaining it. He wrote, "The evolution of the world can be compared to a display of fireworks that has just ended. Some few red wisps, ashes, and smoke." This perfectly illustrates his poetic yet rigorously scientific vision of our cosmos. He imagined the universe expanding from a single, highly condensed quantum of energy. Standing on our little cooled cinder of a planet, we are essentially looking back at the slow fading of those cosmic fireworks. But this wasn't just poetry. It was a firm theoretical prediction of what we would later physically observe in the night sky.
Now, get this for a fantastic piece of historical irony. The term Big Bang, it wasn't even created by Lemaitre or his supporters. It was actually coined by astronomer Fred Hoyle during a 1948 radio interview. Hoyle was a major proponent of a rival idea called the steady-state theory, which basically argued the universe was eternal and unchanging. He used the phrase Big Bang simply to highlight the stark visual contrast between the two models. For years, people mistakenly thought he meant it as a petty insult against Lemaitre's work, but historians point out he was really just trying to create a striking, memorable distinction for the radio listeners. And man, did it ever stick.
All right, on to Section 4, discovering the cosmic fossil.
This is honestly one of my favorite stories in all of science. In 1964, Arno Penzias and Robert Wilson were using a giant horn antenna in New Jersey to investigate radio static. But no matter what they did, they heard this persistent, incredibly frustrating background noise. At first, they thought it was just radio interference from nearby New York City. They even famously got in there and scrubbed the antenna clean, thinking the static was being caused by pigeon droppings inside the horn. But after ruling out the pigeons and the city, what they had actually discovered, by complete, sheer accident, was the cosmic microwave background radiation.
That static Penzias and Wilson heard, that is literally the afterglow of creation. It's often called a fossil radiation. It is the cooled remnant of the very first light that could travel freely through space, about 380,000 years after the initial expansion. But how exactly did ancient light become radiostatic? Well, because space itself has been stretching for nearly 13.8 billion years. Those original, tightly packed, high-energy light waves have been physically stretched out across the electromagnetic spectrum into the long microwave frequencies we detect today. This is cosmological redshift in action, mapping out 13.7 billion years of cosmic history.
And finally, Section 5, Singularities and Unanswered Questions. So if we hit rewind on this massive expansion, the universe gets denser and hotter until we reach a mathematical concept known as a singularity. This is a starting state so extraordinarily hot and dense that standard classical physics as we know it just completely breaks down. Why? Because at a singularity, the gravitational forces become infinite. It forces general relativity, the physics of the supermassive, to crash head-on into quantum mechanics, the physics of the extremely small. When these two frameworks collide at a point of infinite density, they literally produce mathematical nonsense. This is exactly why modern physicists are working so hard to discover a unified theory of quantum gravity just to explain what actually happened at that absolute origin point. Now, because things get so fuzzy at the very beginning, you've probably seen those viral internet headlines lately, the ones claiming that the brand new James Webb Space Telescope has entirely disproved the Big Bang. It's been making massive rounds on social media, but we really have to ask, is there any truth to that, or is it just pure clickbait? Spoiler alert, it is definitively clickbait. It's a prime example of cherry-picked data spreading as misinformation. In reality, JWST actively supports the Big Bang model. Its observations show that the very first galaxies were smaller and grew larger over time, exactly as Big Bang cosmology predicts. Yes, there were some massive surprises in the data. Early galaxies and supermassive black holes appear to have formed much faster and earlier than our previous models accounted for. But that simply means we need to tweak our specific theories of galaxy formation. It absolutely does not mean we throw out the entire established framework of the expanding universe. Which leaves us with a truly mind-bending mystery to wrap up this explainer. If space is constantly stretching, accelerated by a mysterious force we call dark energy, what ultimate fate awaits our beautiful, ever-expanding cosmos? Will it just stretch forever into a cold, dark void in a scenario known as the Big Freeze? Or is there another, completely unforeseen chapter of this cosmic story? It's the kind of question that keeps astronomers up at night, and honestly, I hope it keeps you looking up too. Thanks for learning with me today.